Resultant Vector Part 2. In the previous lecture, we talked about how you can find the resultant vector of majorly two vectors acting at a given point and with different orientation. You can check that out. Now, in this particular one, we'll be talking about several vectors that are acting at a point as well. But this time around, we have the y-axis, we have the x-axis, and each of them forms an angle with either of x or y axis. Now, the first thing we want to do here is that we want to make a table, and the table is going to go like this. So we have the serial number, and then we have the vectors. So we must be able to identify the vectors we are dealing with. Now we must be able to find the x component, and we must be able to find the y component of each vector. So with this now, serial number, we have 6 vectors here. So 1, 2, 3, 4, 5, and 6. So the vector, so let's label them. We have vectors v1, v2, v3, v4, v5, onto v6. So these are the things that we're going to be determining. Let me just partition this now. So we have this, we have this, we have this. Yeah. So the rule is that we want to get the component of each of these guys. We want to get the x component, we want to get the y component. Now there are 3 major rules that we'll be following. The first one is that we have to be able to determine the sign. That is, if we are going to be having a plus or negative vector, depending on the direction. Now, when we are dealing with the y-axis, that is, whenever we are dealing with the vertical, so y-axis or vertical. So here, it is always such that up is positive and down is negative. So what do we mean by here? Any vector that is found up is going to be a positive force, and any vector that is found down is going to be a negative vector. Meaning that the likes of v1, v4, they are positive vectors in the y-axis, and v3, v2, v6, they are negative vector in the y-axis. But when we're talking about the x-axis or the horizontal, in this place, we deal with right and left. Right is positive and left is negative. So if we look at these vectors very well, v1, v5, v2, they are on the right hand side. Therefore, they are going to be positive vectors. v4, v3, they are on the left hand side. So therefore, they will be negative values. Now, the next thing, that's the first thing. So determine whether it is a positive or negative vector in the axis you are dealing with. The second one is the magnitude. So the magnitude are these v1, v2, v3 up to v4 that have been given already. So that one is not really much of a problem. Now, the next thing is to determine whether we are going to be using sine or cosine of any of these angles. Now, I want you to listen to this rule very well. The rule is such that if you are in a particular axis, let's say you are dealing with something on the x-axis, and the angle is made with the x-axis, just like this theta 1. Now you can see that theta 1 is made by v1 with the x-axis. Then that implies that you will be using cosine of this angle in that axis. So just ask yourself the question, which axis am I dealing with now? If the answer is x-axis, where is the angle made with? The answer is also x-axis. Then you will use cosine. You can ask yourself the same question. Which axis am I dealing with? Look at V2. If I'm dealing with y-axis, if the answer is I'm dealing with the y-axis, where is the angle theta 2 made with? The angle theta 2 is also made with the y-axis. Then you will also use cosine. So it doesn't matter whether you're on the x-axis or you're on the y-axis. You can use cosine. The answer just that the axis you are dealing with must also be the axis that the angle is formed with. When the two axes correspond, then you use cosine. But let us say you are on the x-axis and the angle is now made with the other axis. For instance, theta 2. If I'm looking for a component of V2 now and I'm on the x-axis, what you notice is that this theta 2 is actually made with the y-axis. So what axis am I? I'm on the x-axis. What axis is the angle made with? Y-axis. Therefore, I will use sine. If I'm on the y-axis now, let's go back to theta 1. What axis am I? Y-axis. What axis is the angle made with? X-axis. Therefore, I will use sine of the angle. So when the answers of which axis you are and the axis the angle is made with, when the answers are giving you different axes, you will use sine. So you might want to play this back over and over so that it sticks. So let me apply them now. Let's start with V1. So let's start with V1 on the x-axis. As far as the x-axis is concerned, V1 is on the right. Therefore, we have a positive vector followed by the magnitude, like I've said. So that's V1. Then the angle theta 1 is made with the x-axis. And which axis am I dealing with? Also the x-axis. Since these two answers are the same, I will be using cosine of that angle, cosine theta 1. That makes sense. Let us go to V2. V2, which is here, is still on the right hand side. Therefore, it will still be a positive vector since I'm still on the x-axis. So I have positive V2 like that. The angle theta 2, I'm on the x-axis, but the angle theta 2 is made with the y-axis. That is a different thing. I'm on the which axis am I? X-axis. Which axis is the angle made with? Y-axis. So since they are different, so I'm going to be using sine of theta 2. And this is the process we follow all through. Let's quickly go to V3 like that. What is V3? V3, as you can see, is on the left hand side. Therefore, it's going to have a negative sign here. So we have negative V3. Then, which axis am I? X-axis. Which axis is the angle theta 3 that the V3 is making? Is making it with a y-axis. So I'm on x-axis. They are different. So therefore, I will be using sine theta 3. Now let's go to V4 quickly. V4 is also on the left hand side. So since V4 is on the left hand side, that will be negative V4. Now let's look at that. Angle theta 4 is made with the x-axis, as you can see here. Then I'm also currently on the x-axis. Therefore, I'm going to be using cosine of that theta 4. Now let's go to V5. Now V5 is a special case. Whenever you see a vector lying directly on any of the axes, that is, whether it's lying directly on the x-axis or on the y-axis. For instance, now in this case now, this is lying directly on the x-axis. Therefore, I only need to consider the sign and magnitude. What we say about V5 is that it's directly on the right hand side. So which will mean we have positive V5. Now with this V5 now, I don't need to do any sine or cosine of anything. It's just the direction which is on the right hand side, and that is positive, and the magnitude, that's all. Let's go and look at V6. What you notice about V6 is that V6 is also directly on the y-axis. What happens is that when a vector is directly on an axis, the component for the other axis will be 0. So this thing has business with the y-axis only. V6 has business with the y-axis only. Therefore, its x component is going to be equal to 0. So we are done with x-axis. Let's go over it again and let's do y-axis. For the y-axis, we start with V1 again. As we can see, V1 is at the top. Since it is at the top, so up is positive for y-axis. So we have plus V1 again. Now look at the angle. I'm on y-axis, but the angle is made with the x-axis. Therefore, they are not the same thing. I will use sine of theta 1. So when the axis you are dealing with and the axis the angle is made with are not the same, you will use sine. Let's go to V2. V2 is down in this case now. So we are dealing with y-axis, don't forget. So V2 is down, therefore it will be a negative V2. And then the angle theta 2 is made with the y-axis. And I'm doing y-axis at the moment. So if the axis and this are the same, then I will use cosine of theta 2. Let's proceed. For V3, V3 is still down as well. So it's down. So that will still be negative V3. And then we have the angle theta 3 is made with the y-axis. Therefore, it's going to be cosine theta 3 since I'm still on the y-axis. Let's go to V4. V4 is up now. So we have a positive V4. A positive V4. Now let us look at angle theta 4. Angle theta 4 is made with the x-axis, but I'm currently dealing with the y-axis. Since they are different, therefore I will use sine of theta 4. Now let's go to V5. V5 appears directly on the x-axis, which means that its y component will be 0, nothing. And finally, V6 appears directly on the y-axis. We only need to consider the direction and the magnitude. And since it is down, we know down is negative as far as the y-axis is concerned. So we have negative V6. Now that we are done with this table, so the next thing we want to do is that we want to get the net result. So we add everything on the x-axis, and we also add everything on the y-axis. That is when we have gotten the result, putting the signs into consideration. So we do the summation of everything. Then our resultant will then be the square root of this summation. So let me call it sx squared plus sy squared. Let me call this one sx, and let me call this one sy, assuming that that's the net result we get. So resultant will be given as this. Now, the next thing you want to do is that you want to find the direction. Generally, the direction is always given as the arctan of sy over sx. Now, but this is what you need to do. You need to do a little bit of trigonometry. If these two guys, so I will give you different scenarios now, what can happen, depending on what your sy and sx are. So quickly, let me pull this down. Now, let us say that your sy is greater than 0 and your sx is greater than 0. That is, both of them are positive. Then you can just apply this formula directly. That will be your direction. So theta is still theta. Now, let us say that in this situation now, let us say you have sy is greater than 0 and you have sx is less than 0. That means the y component is positive, but the x component result that you get is negative. What will be your direction? Your direction will be 180 degrees minus theta. So whatever it is the theta that you get, you subtract it from 180 degrees. So what I'm trying to say here is that always use the absolute value here. That is, use the positive value. Don't bother about the sign. Just find the ratio. Then whenever you are done finding the ratio, depending on the sign of your y component and x component, then you can determine which one you will use. The other one here is if both of them are negative, your y component is negative, your x component is also negative. What will you do? After you have gotten the theta in this place, so all you have to do is to add the theta with 180 degrees. So you have 180 degrees plus theta. So that is what you will do, because if both of them are negative, that means that whatever angle you get here is formed with this. So you add it with 180. And lastly, if sx is greater than 0 and sy is greater than, that means that your x component is the positive one and your y component is negative. What do you do in this situation? You subtract your theta from 360. Subtract your theta from 360. So that is how you find the direction for any case that you are given. So a recap is, when you have gotten this net guy, pick their positive values, ignore their negative or whatever sign. Pick their positive value, find the ratio of the y component to that of the x component, find the arctan of that, whatever theta you get. Now, use this chart to determine where your resultant force is going to fall and use it to determine the direction. So for this first place, it's still going to be theta. So this is how you find the resultant vector of vectors of this form. If you want to see more videos like this, subscribe and follow. I'll see you in the next one.